Alright, hello geometry. So you may have noticed this is 2-3 part 2. The reason it's part 2 is because there's part of this that we didn't get to on Tuesday, which is either yesterday or a couple days ago, depending on when you're watching this, that I did want to make sure that we hit. So we're looking at conditional statements again, but this time we're looking at whether or not they're true. So whether they're true or false. So when we were doing the converse, inverse, contrapositive, I said, okay, don't worry for now about whether or not these things are true. Now we're going to look at some conditional statements and whether they're true or false, and we're going to be looking at counterexamples and also some weird cases that happen with those statements that you were laughing at during class with, like, if a cat is a reptile or something. So we'll get to those in a moment. Okay. So we've got a statement that says, if a number is even, then it is divisible by 2. So, true or false? Okay, even numbers, that's what makes things even in the first place, is they're evenly divisible by 2, so that one's true. I don't think I'll get any argument on that one. That one's true. And if it's true, we're just going to write that as true, and maybe draw a little smiley face. Okay, so we've got, if a number is even, then it's divisible by 4. Okay. So what we're looking for, if we wanted to figure out whether this is true or false, is we're looking for, is there a number that's even that's not divisible by 4? And you're probably already coming up with things like 2, 6, 10, 14, and so on. And all we need is one counterexample in order to prove that that statement is false. So this one's false. And any one of these would be a counterexample. You can jot them all down if you want, but we really only need one of them. So if I said 2, we've got a number that's even. So that first part is true. That'll be important later. But it's not divisible by 4. So if we're looking for a counterexample, we're looking for something where the first part is true and the second part is false. So then it's something that fits the first part, but not the second part. Okay? Now I've got, if a number is odd, then it is divisible by 3. I hope the orange showed up okay. So, is everything odd divisible by 3? Well, if we start thinking of odd numbers, like, okay, 1, 3, 5. Okay, well, we've already hit 2 that aren't, because 1's not, 3's not, oh, 3 is, hello, 5 is not, 5's not, 7's not, 9 is. So there are some that are, but if there are any that aren't, then this is false. So this is false. And any of these would be a counterexample. And I mean, you could keep going. You could say 11. You could say 13. You could say anything that's not divisible by 3. So we've got numbers that are odd. So those fit that first part, but they're not divisible by 3. So you have examples where the first part is true, but the second part is false. There's a reason I keep repeating that. It's going to be important in a moment. Okay. Although if an animal is a cat, then it's a mammal. Yeah, cats are mammals. Okay, that one's true. Because, think back to biology, mammals, have fur, have milk, give birth to their young. All those things make a mammal. Yeah, those are cats. Okay. Not going to get any argument on that one. What if we flip it around and say, if an animal is a mammal, then it's a cat. So we got our converse going on there. Where we have the converse there. So if it's a mammal, then it's a cat. Is that one true? No, because I'm a mammal. I'm not a cat. Or you could say a dog. Or you could say something like an elephant. And at this point, you're probably going, well, duh, Miss P, of course. Okay, so this one's false. And again, any of these are a counterexample. So these are things that make the first part true. So these are all mammals, but they're not cats. Believe it or not, I'm not a cat. Okay, now we're going to get back into the things that look more like geometry. So if 2 angles are vertical, then they are supplementary. Okay, so thinking back to vertical angles, those are the ones that were kitty corner if I make an X shape. So these ones. So we want to know, are those going to be supplementary? And supplementary, remember, means they add up to 180 degrees. So I mean, even just looking at that, that looks pretty acute to me. That looks pretty acute to me. So I think we drew a counterexample right there. Now, again, there are some that are. So if I drew some right angles, those two would be supplementary. But that's the only time that's going to happen. And again, all we need is one counterexample to make that false. And in fact, you could use either pair here, because you've got two that are acute here. Those aren't going to add up to 180. And you've got two that are obtuse here. That's going to add up to more than 180. Two lines in. There you go. So either of those would be a counterexample. So those are angles that are vertical. So that part's true. And then the second part is false, because they're not supplementary. Okay, let's flip that around and say if two angles are supplementary, then they're vertical. So we're looking for, are there supplementary angles that aren't vertical? Well, yeah, because if I have two angles here that make a linear pair, if I say this is 140 and I say this is 40, and even if I don't give them names, those are still supplementary because they're making a straight line. Okay, they add up to 180. Those aren't vertical because they're not across from each other in X. So there's our counterexample. I can spell. There you go. So those are two angles that are supplementary, so that part's true, but they're not vertical, so that part's false. And the reason I keep harping on that true-false thing there is that's what makes something a counterexample. This is something that makes your hypothesis true and your conclusion false. So that's what a counterexample is, and that's what we need in order to make an if-then statement, a conditional statement, false. So in order for it to be false, we have to have one of these. The reason that's important is because if I have something like this, if a cat is a reptile, then 2 plus 2 equals 5. Now, admittedly, that probably screams like it should be false, because cats are not reptiles. And 2 plus 2 definitely does not equal 5. So just looking at that, looks like it should be false. But in order for it to be false, we have to have a counterexample. And in order to have a counterexample, we have to have something where our hypothesis is true, but our conclusion is false. And if our hypothesis is something that's always false, we can't have that. So we can't have a counterexample where this is true if that's never true. Because a cat is never a reptile. I mean, I guess you could take an alligator and name it cat, but we're ignoring that for now. Cats are not reptiles. So cats are not reptiles. So the fact that we can't have a counterexample to this means that this whole statement is true, even though both parts of it are false. So that's the kind of funky thing. Both parts of it are false, but that means that your whole statement, if this, then that, that's true. That's kind of weird. And it also works that way if you have something like this. So we have, if a right angle is 75 degrees, then 17 is odd. Okay, you're probably going to go, well, a right angle doesn't have 75 degrees, so that's false. But that part's true. So again, we can't have a counterexample, because in order to have a counterexample, we need to be saying if something true, then something false. So we need to add if something true, then something false. And we can't have that if this is never true. So if we got something where this first part is false, always, right angles are never 75 degrees. They're just not. And you can't even name an alligator cat on that one. That's just never true. So if we have something that's never true, then we can't have a counterexample. So this whole statement is true, even though right angles are never 75 degrees, because we can't have a counterexample. Because in order to have a counterexample, we have to have something where this first part is true, and we can't. So you may have noticed if we have something that's false right away, it doesn't matter whether this second thing is true or false. So if we have if and then something false, weirdly, that makes your whole statement true. So that's the kind of weird part that I wanted to make sure that I mentioned. So that's why we're hitting this twice. Also, I might be stalling because the next section is something that I kind of wanted to cover in person. So, but this is important too. Okay, so numbers are in the description below. They're also up on Google Classroom. This is going to be due on Monday. If we're back in school on Monday, you can just hand it to me then. If we get news over the weekend or whatever that we're not going to be back on Monday, then just go ahead and take a picture of it and either upload it to Google Classroom or email it to me. Either one's fine. All right, so that's that, and hopefully I will see you Monday.